In this section, we're going to simplify, multiply, and divide rational expressions. And before we do that, you should understand what the definition of a rational expression is. And so if you look down here, a rational expression is an expression in the format of p over q, where p and q are polynomials and q cannot equal 0. And the reason why q cannot equal 0 is because division by 0 is not defined. So here are some examples of rational expressions. 6x minus 5 over 2x minus 4, and x over x plus 4. Now, those are expressions. The following are rational functions. So when you just say f of x is equal to a rational expression, you have what's called a rational function. And when you're working with rational functions, it's important to understand what the domain of the function is. And basically, a domain of any function is the set of values that can be used as replacement values, values that you can replace x with so that the function is defined. And so on a rational function, basically the domain is any real number such that the denominator is not 0. Because if you have 0 in a denominator, you do not have a defined value. So let's look at these first two examples. We're going to find the domain of each. And so for a rational function, we basically just start off by saying the domain is all real numbers except, and our job is to find out what that exception is. And that exception is when the value of x that's going to make that denominator equals 0. So what we'll do is we'll basically set that denominator equal to 0. So we'll take 2x minus 4, set it equal to 0, and solve it. So we'd have 2x equals 4, or x equals 2. Now, since that is the value for which 2x minus 4 equals 0, that actually has to be the value that is not in the domain. So we would say x cannot equal 2. The formal way of writing that in set notation is x such that x cannot equal 2. On tests, I'm usually pretty lenient about this, and I'm perfectly fine with you saying x cannot equal 2. We're basically assuming that the domain is all real numbers except 2. So this other one over here, part B, the denominator is x plus 4, so I basically just have to throw away any values for which x plus 4 equals 0. This you can do in your head, but I'll do it out. We're going to take x plus 4 and set it equal to 0. We get x equals negative 4, and so the domain is x cannot equal negative 4. Now, the next thing we want to do in this section is to simplify rational expressions. And so we'll start off with one that you actually should already know how to do, but just as a quick review, when you have a monomial in the numerator and a monomial in the denominator, you don't have to factor this. We just want to reduce. So we say that 2 goes into itself once, goes into 4 twice, and then the x's you have to decide where is that x going to end up, in the numerator or the denominator. And the rule of thumb is that the variable is always going to end up where the exponent is larger, and this is so that you can leave your answer with positive exponents. So if I cross off the x cubed, down here we're going to get x to the 5 minus 3. Now the y's are going to end up in the numerator. I cancel that, and I'm going to subtract off the 2. So in the numerator I'm left with 2 y to the 6th all over x squared. And that is a simplified rational expression. Now for all other problems, when you don't have a monomial, basically your job is going to be to factor the numerator, factor the denominator, and cancel common factors. Let's go ahead and simplify this rational expression. We'll first factor the numerator, which should be x plus 2 times x minus 2. The denominator is a trinomial with a coefficient of the lead term being 1, so I need an x and an x. The last term is negative, so I know the signs must be different. I'm looking for two numbers whose product is 8 and whose difference is 2. And it has to be, the larger number has to go with the middle sign, so we'd have a 4 and a 2. And now I'm going to cancel the x plus 2's, and I'm just left with x minus 2 over x minus 4. Right, we've got one more where the factoring is a little more complicated, and we're going to have to deal with some factors that are opposites of each other in this one. Let's go ahead and factor the numerator. It's the difference of two squares, so it's going to be 5y plus 4x times 5y minus 4x. And now the denominator, I'm going to use the bow tie method, and I'm also going to ignore the y squared for a minute and just deal with this as if there was no y there. So I know I need 8 and a 1 is a factor of 8, or 4 times 2. And the factors of 5 are 5 and 1. Last term is positive, so I'm looking for a sum. Sum has to equal 14. If I arrow diagonally here, I get the 10 and the 4 that I need. I'm going to circle across. So I put in my parentheses. I know the 4, it's going to be 4x with a 5. And then the 2 would be a 2x with a 1. But I know in order to get that y squared, I need to throw in a y. I also know that the last term is positive, so the signs must be the same as the middle. Now when you look at this, it's not obvious that there's anything to cancel it. Right now there's no factors that look exactly the same. What we do have is the case of two opposites. So 5y minus 4x and 4x minus 5y are opposites of each other. When you cancel opposites, you cancel them both and you really just replace with a negative 1. And I'll show you why that works. And the basic idea is this. If you have a minus b over b minus a, the answer is always negative 1. Giving you some specific examples, if you had a 4 minus 9 over 9 minus 4, you would get negative 5 over positive 5, or negative 1. You can do this over and over again. What's really going on is that when you have the scenario a minus b over b minus a, you can factor a negative 1 out of either the numerator or the denominator. So when you factor a negative 1 out of the numerator, you get negative a plus b all over b minus a. Well, negative a plus b is the same exact thing as b minus a. You can rewrite it if you want. All over b minus a. And all you're left with is that negative 1. And so when you cancel that, you're left with a negative 1. Do not put a negative 1 in both places. You can put a 1 down here if you want. But because if you put a negative 1 in both places, a negative divided by a negative is a positive. So what you're left with, generally when you have that factor of negative 1, you can put it right next to the fraction bar. And your answer will be 5y plus 4x over 2x minus y. You can also distribute that negative 1 either to the numerator or to the denominator. You can write it like that. You could put the negative with parentheses in the denominator, or you could distribute it. These are all considered equivalent expressions. So in the next video, we'll look at multiplying and dividing, which is very similar to just simplifying.